Okay, let's look at this again, because there is one point I don't really understand. I prepared something here. We have Earth and its orbit around Sun in summer and in winter. In this direction is Polaris, and it's the exact same angle here and here, because Polaris is so far away that it's almost parallel. We want to point our telescope directly to Polaris. For this also has to be parallel. We have to put it to this angle, which is the same angle as in the latitude of your position. When it's 12 hours later and our telescope is now on the day side due to Earth's rotation, this is the same angle. This is all parallel. We only can't see Polaris from there because the sun is too bright. Now, half a year later, when we direct our telescope to Polaris, this is already parallel, and because the angle of Polaris in summer and in winter is absolutely the same, the angle of the telescope to spot Polaris is also the same. It's still the same angle as the latitude of your position. We don't have to align our telescope in another angle because it's not there or there, it stays the same. So here comes another thing which makes me sure that we live on a globe and not on a flat earth. Here we see the globe with the longitude and latitude lines. We have the rotational axis going through here. In this direction is Polaris. Very far away, of course. When we are at a latitude of 50 degrees north, that's this line here, and we build up our telescope, we have to align it parallel to the rotational axis. Here is Polaris. And this angle is the same as the latitude. It's 50 degrees. When we build it at the equator, which is 0 degree, then it's parallel to the ground at 0 degree. When we build it at the North Pole, for example, we have to direct it upwards at 90 degree. This geometry, how we have to align our telescope with the latitude lines, and each latitude line is 690 miles apart. So for every degree, 1 degree equals 69 miles. So between 40 and 30 degree, you have 690 miles. Just mean 50 and 50 degree or 690 miles. And this doesn't work on a flat earth. This only works on spherical geometry. If we would live on a flat earth and Polaris would be that far away, it wouldn't matter where we stand, we would have to align our telescope everywhere at 90 degrees to be parallel with Polaris. if Polaris would be much closer, the whole thing looks a bit different. Then we would have a telescope pointing at Polaris from here, and we have a telescope pointing at Polaris from here. And the closer you come to Polaris, let this be the North Pole. This would be also 90 degree, but the rate of change here is completely different. It's not like on a sphere where you have for the same distance the same change in angle. And this would be Polaris. Let's make a triangle. This is directly above North Pole. Okay, so the angle we have here, when you move towards Polaris, so the distance between this and this doesn't make a big change in the angle. But if you make the same distance again, the change in the angle gets a lot bigger until you came to the 90 degrees. This is different geometry and a change of angle dependent on your latitude as it is on a spherical Earth. And spherical Earth does fit our observations. It all adds up perfectly, and in flat Earth it doesn't. On a flat Earth there's also no point where we can put our telescope and the angle to Polaris becomes 0. So we would have to put it in the air so that we are parallel to the ground to see Polaris. There's also no point where we put our telescopes and Polaris vanishes, so we see the other celestial pole, Sigma Octantis, on the other side. And look there. This makes no sense on a flat Earth. On a globe Earth, on the other hand, this works perfectly out. At the equator we can see both Polaris and Sigma Octantis, which is the southern star near the celestial pole. So this is as well 0 degree to north, as well to the south. And in south this works also the same. At, let's assume, 20 degrees south, when we put our telescopes here, this angle is also 20 degrees. And this works the same when you come closer to Antarctica. When you look at all this at the position of Polaris, you see it makes perfectly sense on a globe Earth and absolutely no sense on a flat Earth. I know you said you haven't been to school, but you neither are uneducated nor unintelligent. You have profound knowledge of basic geometry, enough to understand the relation between angles and distances. Okay, you made this one mistake about the position of Polaris, where you said it should be at another place in winter than it is in summer, which I don't really understand after you got all the other stuff absolutely right. The question is, have you even considered to look a bit deeper into the topic? Because in my opinion, it gets quite obvious really quick that flat Earth doesn't add up a bit. This is no offense, it's only my suspicion that your belief in a flat Earth doesn't have to do anything with any considerations about geometry, but has a complete different cause. And I think that's the case for anyone who denies the globe. I only hope that geometry helps to reconsider your position. I also hope you enjoyed this video, and I'm eager to hear your response. Goodbye.